Right. 11th assignment of solutions. First numerical. Calculate mass fraction of methanol in an aqueous solution containing equal number of moles of methanol and water. Say number of moles of water is equal to number of moles of methanol is equal to 1. Therefore, weight of water will be 18 grams. Weight of methanol will be molecular weight 32 grams. It means weight of the solution will be 50 grams. So methanol percentage will be weight of methanol divided by weight of solution into 100. This is 64%. Second, calculate mass percent of sulfuric acid in its 10 molar aqueous solution. Density of the solution is 1.6 gram per cc. Say solution is 1 liter. By definition, 10 molar solution means there are 10 moles of sulfuric acid in 1 liter of the solution. It means sulfuric acid will be 10 moles. 10 moles will be 980 grams. Molecular weight of sulfuric acid is 98. 98 into 10, 980 grams. Now, weight of this solution will be 1000 divided multiplied by density. Density is 1.6, 1600 grams.
मेरा फोन का है.
Sorry? Please switch on my mic, please. Mic off kariye. Adit, yes. So calculate mass percent of sulfuric acid. So percentage of sulfuric acid will be weight of sulfuric acid divided by weight of solution into 100. This will be the answer. Numerical number 3. Calculate Henry's law constant if the solubility of H2S in water is 0.001 molal at STP. This is a very important numerical from board point of view. Point 0.0012 molal solution of H2S means what? 0.0012 mole of H2S present in 1 kilogram of solvent. And since this is aqueous solution, it means solvent is water. So water is 1000 grams. Now we have to calculate Henry's law constant. Now this is moles and this will be 55.56 moles divided by molecular weight. This is at STP. Pressure of any gas at STP will be 1 atm. So Pg is 1. KH we have to calculate into Chi-G. Mole fraction of gas will be 0.0012 divided by this plus this. Now you can neglect this and then calculate. I'm writing 0.0012 plus 55.56. This you can neglect and calculate. This answer will come in atmospheres. You can leave the answer as such in atmospheres, or you divide by 1000, you'll get the answer in kilo atmospheres as given in the worksheet. Fourth numerical. 260 grams of aqueous solution, density 1.04, contains 10 grams of solute and exerts OP of 4.82 atm at 20.5 degrees centigrade. Calculate boiling point. K at Kb is given. Pi is 4.82 is equal to IMRT. I will be 1. Number of moles will be we'll calculate number of moles. Pi V is equal to no 4 pi into V. Volume will be weight of solution divided by density. Weight is 260 divided by density is 1.04. Again divide by 1000 so that it is converted into liters. So this is pi V is equal to I N will calculate R and temperature. Whatever is the temperature given, you convert on Kelvin scale and use here. This temperature is given. You'll calculate the value of number of moles of solute. This will come out to 0.05. Now, elevation and boiling point will be I is 1, Kb is 0.52 into molality. Molality will be number of moles of solute into 1000 divided by weight of solvent. Weight of solvent will be weight of solution minus weight of solute. It is given 10 grams of solute. You'll calculate the value of elevation and boiling point. This will come out to 0.104. So boiling point will be 100 plus elevation. That will be your answer. Fifth numerical. Calculate molality of an aqueous solution of sulfuric acid in which mole fraction of sulfuric acid is 0.143. Say number of moles of water plus number of moles of sulfuric acid is 1. You can assume X, you can assume 10, you can assume 20, any value you can assume. I'm assuming 1, that will become easy. Therefore, number of moles of sulfuric acid will be 0.143 and number of moles of water will be total minus this, that is 0.857. Number of moles of sulfuric divided by total will be mole fraction. So mole fraction will be equal to number of moles in this case. Now we have to calculate molality. So molality will be number of moles of sulfuric acid into 1000 divided by weight of solvent. Solvent will be number of moles multiplied by molecular weight of water. So 0.857 into 18. This will be molality of the solution. Next, sixth numerical. What volume of water should be added to 4 liters of 5 molar solution so as to dilute it to 2 molar? Say water added is equal to X liters. We have to calculate the value of X. I'm using the formula M1V1 is equal to M2V2. Initial molarity 5, initial volume 4, final molarity 2, final volume will be initial volume plus X liters of water added. This will be 4 plus X. X will be your answer. 7th, 2.56 grams of sulfur when dissolved in 60 grams of carbon disulfide elevated its boiling point by 0.4 degrees centigrade. Calculate molecular formula of sulfur in the solution. Kb is 2.4. Say molecular formula of sulfur is Sx. We have to basically calculate the value of X. Therefore, molecular weight of Sx will be 32x. Elevation is 0.4 is equal to Kb is 2.4 into molality. Molality will be weight of solute divided by molecular weight is 32x into 1000 divided by weight of solvent is 60. X will be your answer. This is one way. Second method is use 32 as the atomic weight and calculate the value of I, Vector factor. Value of I will come out to 0.125. 0.125 means 1 by 8. 1 by 8 means sulfur will exist in the form of octamer. Octamer means formula will be S8. So you can use that way also. Eighth, radiator of a car has a capacity of 5 liters. It is filled with an aqueous solution. Density of solution is 1.04. Solution of glycol and can be used at a minimum temperature of -9 degrees centigrade. It means depression and freezing point will be 9. Calculate the mass of glycol. Kf is given. See, depression is 9, I is 1, Kf into molality, weight of solute, glycol that we have to calculate. Yes, that we have to calculate, divided by molecular weight into 1000 divided by weight of water. See, solution is 5 liters. Its weight will be into density. This will come out to 5200 grams. So weight of solution in the radiator is 5200 grams. So 5200 minus weight of solute will be the right substitution, and WB is weight of glycol required. That is your answer. Ninth, how many grams of urea should be dissolved in 168 grams of water to prepare a solution which will have a difference of 105.1 degrees centigrade between its boiling point and freezing point? Kf and Kb are given. See, boiling point will be 100 plus elevation. Freezing point will be 0 minus depression. We are given difference of these two is 100.5, and this will be 100 plus delta TF or delta TB minus 0 minus delta TF. So difference of boiling point and freezing point is given. So this will come out to 5.1, and that is equal to delta TB plus delta TF. Right? Now, delta TB will be equal to, see, I value will be 1 for urea, will be weight of urea divided by molecular weight into 1000 divided by 168 grams of water into Kb will be 0.52. This will be Kf is 1.86. Rest will be same. Wb divided by 60 into 1000 divided by 168. In fact, this part is common. You can calculate the value of Wb. Now coming to theoretical questions. Vegetables and fruits that have dried up slowly swell up when placed in water to regain a normal shape. Why? Answer is due to endosmosis. Will the process be faster at high temperature? Yes, process will speed up at high temperature. The reason is at high temperature, mobility of particles, mobility of solvent particles across semi-permeable membrane will increase, right? That is the reason. What is the effect of temperature and atmospheric pressure on osmotic pressure? There's negligible effect of atmospheric pressure, and effect of temperature that you can see the relation, it is directly proportional. OP increases with increase in temperature, but pressure has negligible effect. Arrange 0.1 molar solutions of potassium sulfate, glucose, and sodium chloride in the order of their increasing boiling point. Remember, you have to think in terms of I value. For potassium sulfate, it is I is 3. Second is glucose, I is 1. Sodium chloride, I value is 2. higher the value of I, higher is delta TB, and higher is the boiling point, right? So glucose will be minimum, potassium sulfate will be maximum. Second part, we have to arrange in increasing freezing point. Again, higher the I, higher will be the value of delta TF. And remember, higher the value of delta TF, lower will be the freezing point. So freezing point of K2SO4 will be lowest and glucose will be highest. Oh, that's all. These were theoretical questions to be discussed here in the class.